Hello and welcome to the lecture on bottom-up and top-down approaches in nanotechnology. So, for synthesizing or fabricating the nanostructures, there are two approaches. One is top-down and the other is bottom-up. So, typically in top-down, attrition or milling, it is a typical approach for synthesizing nanomaterials using top-down approach. Whereas colloidal dispersion, it is a good example for bottom-up approach. For synthesizing synthesis of nanomaterials using colloidal synthesis method, in that method we are going to synthesize nanomaterials, and that method is bottom-up approach. Whereas lithography, it is a both top-down as well as bottom-up because we are going to grow the thin films, which is a bottom-up approach. So thin films are grown by depositing small species like atoms or ions, and the thin film is grown. So that is a bottom-up. Whereas then after growing that, the etching is done to attain the desired level of thickness. So which is a uh, top-down approach. So lithography is both bottom-up as well as top-down approach. So it is called hybrid approach. And nanowires which are made by lithography, they are not smooth, and those nanowires contain a lot of impurities and structural defects on surface. Whereas nano lithography and nano manipulation, or these are commonly bottom-up approach. So these are the common bottom-up approaches for synthesizing nanomaterials. Both top-down as well as bottom-up approaches play a very important role in the modern industry and nanotechnology. Both methods have advantages as well as disadvantages. So the biggest problem with the top-down approach is the imperfection of the surface structure. So in top-down, uh, like while doing uh, etching, for example, in top-down when we do etching, it causes significant crystallographic damage to the process, and it may add defects um, during the etching steps. So surface imperfections would have a significant impact on the physical properties and surface chemistry, because in case of nanomaterials, the number of atoms, that is surface over volume ratio, is more compared to bulk materials. Bulk materials has large volume, um, and the surface is small, whereas for nanomaterials the volume is less, and most of the surface will be there. So the surface to volume ratio is more, hence surface imperfections would cause a great impact on the properties of the nanomaterials. So, so one example of this one example of the physical property that gets affected is electrical conductivity. So surface imperfection would result in a reduced conductivity due to inelastic scattering. We know that in inelastic scattering, the kinetic energy is not conserved of the incident particle. So this results in the generation of heat. So the kinetic energy will get converted into heat, and this will lead to excessive heat. So it will be a challenge for the device design and fabrication. So regardless of the surface imperfections and other defects, the top-down approaches may introduce. So it plays a important role in the synthesis and fabrication of nanostructures and nanomaterials, despite having these demerits like surface imperfections and other defects. So, in bottom-up approach, the nanomaterial synthesis is done by building an atom by atom. So, like one atom adding to another, and so forth in by adding so to a very large scale, the nanomaterials are synthesized. So, the examples of bottom-up approach is like production of salt and nitrate in chemical industry, the growth of single crystalline material, and deposition of films in electronic industry. These are the examples of bottom-up approach. For most materials, there is no difference in the physical properties of materials, regardless of the synthesis routes, provided that the chemical composition, crystallinity, and microstructure of the material are identical. But of course, different synthesis and processing approaches will often result in appreciable differences in chemical composition, crystallinity, and microstructure of the material. This is because of kinetic reasons. So, consequently, the material will exhibit different physical properties. And the another example of bottom-up approach in organic chemistry is that or in polymer science, polymers are synthesized by connecting individual monomers. So one monomer is connected to another monomer, and more monomers are connected to form a polymer. And in case of crystal growth, so this is another example of bottom-up approach where growth species such as atoms, ions, and molecules, after they are impinged onto the growth surface, so they assemble and form a crystal structure. Bottom-up approach it plays a important role in fabrication and processing of nanostructures and nanomaterials because as the structures fall into a nanometer scale, there is a little choice for a top-down approach. All the tools that we have possessed are too big to deal with such tiny objects. So, bottom-up approach it promises a better chance to obtain nanostructures with fewer defects, more homogeneous chemical composition, and better short and long-range order. This is because the bottom-up approach it is driven mainly by the reduction of Gibbs free energy, so that nanostructures and nanomaterials produced are in a state that is closer to thermodynamic equilibrium state. On the contrary, whereas top-down approach most likely introduces internal stress in addition to surface defects and contaminations. So these are the differences between top-down and bottom-up approaches. Thanks for watching this video, and please subscribe to get more lectures.